So, hello everyone. Like in this session, I'm going to talk about building data platforms with event-driven architecture and orchestration. About myself, I am Sepehr Mohammadi. You can call me Sepi, and I work as a data engineer at Cred. I'm quite passionate about building data and AI platforms, and like I usually I'm continuously following this cycle, but by like learning something, building something on top of that, and then presenting that. And like actually recently I've started to do more presentation because I think that this presentation is kind of like completing the learning cycle for me because I'm hearing like the feedback from the people. I can improve the thing that I have built, and like definitely these things like communities is helping us to share more knowledge and learn more stuff. And honestly, like there is one more thing that like when I learn something, I try to learn like the in and out of that and like learn everything about it, and then I try to build something with the best practices. Then I feel like I'm the best data engineer in the world. I think until I present that to some people and they like start to roast me and they say like my architecture is just shit, or when I put the model in production and it fails in production, then I realized that kind of maybe I'm the worst data engineer in the world. But like I was kidding, like my models they never fail they never fail in production unless they do in the first day. About Cred, Cred is a fintech company that has like operations in Nordics, Netherlands, and Belgium. And where like traditional banking, they are not taking the risk and trouble to help small businesses and finance them. We are there to take the risk and like finance small businesses with different products such as like business loans, credit cards, and factoring. So what we're doing is like we are trying to empower small businesses. So, like to start with the agenda, like first of all, I'm going to talk about what exactly we are trying to build here, like what exactly is a data platform, identify like the capabilities that we want to implement there and like the characteristic that it has. And then I will talk a bit about like event-driven architecture and like more specifically about the choreography pattern. And then I will continue with like talking about orchestration and eventually how we can combine choreography and orchestration like to achieve more like advantages from this architecture. So to talk about like data platform architecture, like historically speaking, like years ago, data engineers they used to create ETL pipelines that they were taking data like directly from the data sources and putting them like in the data warehouse. So like stakeholders, they were telling them that we want like these data models or fit these like calculations, and they were responsible to like write a rigorous ETL pipelines, extracting from the source, doing some like spaghetti transformation, and then loading the data into the data warehouse. And like by doing that, whenever like the stakeholders they were asking for a new data model on the same data, they had to write a new ETL pipeline extracting data from scratch and doing all the same again. But with this new architecture, as we can see in this picture, now we have more components between the data source and the consumption layer. To start with, we take data from the data sources and we ingest them into like a storage that we have. And like this ingestion can be like in batch processing jobs or like it can be in real-time processing jobs. And then when we have the data somewhere like in a storage, like S3, then we do some like metadata management and like we create catalog to do like to take care of the partition of the data, to take care of like schema evolutions and like open table managements. Then when we have the data in data lake, we start like to create our data warehouse. Data warehouse can have like several architectures, but the one that I'm showing here is following like is a really like common one used a lot in the industry. And like the one that I have here is like having three stage of like analytic layer. The first one is like the bronze layer or the staging layer that has a one-to-one connection with the raw data that we had already stored in S3 or like in our data lake. Then like the next step is the analytics or the silver layer, and like most of the analytics that like for example when we want to write a query to see what exactly is happening there and how the data looks like happens on this layer, that we have like aggregation on the raw data from the staging on the client or contract level, and eventually when we do more aggregation on the product or on the market level, we put that in the next layer called like Mars or gold layer, where it can be used for like high level decision making around the organization. And then eventually the data platform should be able to satisfy all different use cases and requirements. It can be like operationals for like reporting or like marketing funnel. It can be analytics, and it can be like some like AI and ML use cases. And sometimes we directly get the data that we have in the data lake. Like, for example, we use the data for machine learning training and other stuff. And in this case, when we are putting use cases directly on the data lake, and at the same time, we are using the data warehouse, we call this architecture a data lake house. And also, by having this architecture, we can use the data on the ingestion, like when we are passing the data in real time, we can use that for like decision making on the inference models that we had like built before. So to talk about like the characteristics of the data platform that we are looking for, like what are the capabilities that we want this to have. I can start with like a scalability. A scalability is satisfied by having like a cloud native infrastructure and all the like serverless tools that we have there. Like for example, we can increase the amount of data, like we can have like more load of data because like for example, like S3 can handle all like different volume of data that we are ingesting there. Then we have like flexibility, which is so important for us. And thanks to the data lake, we are having like lots of flexibility in this architecture. For example, like we can ingest data in both like batch and like real time, and also we can store different types of data. For example, like structured data, semi-structured or non-structured data. And the last one, which is like I think is the most important one, is the adaptability. Adaptability means that as the business is evolving, the models that we need to generate, or like the machine learning models that we are going to build, they are changing. Like every day you hear of a new model that is like out, and you want to test that. So your like data platform should be adaptable enough so you can integrate these new use cases easily without like modifying the whole structure of the data platform a lot, or without needing to go extract the data from the first place from the data sources. For example, if you have an like transactional database, which is the backbone of like some part of your data, you shouldn't extract the data from the transactional database every time that you want to use a data for a different use case. So the next like characteristic of this platform is that the components are decoupled. As you can see here, each component is responsible to do one thing, and though they are dependent on each other, for example, like the transformation layer is using like the metadata of the data that had been created on the data lake, but still they are loosely coupled. It means that like modifying one of them shouldn't affect the other one, or even the failure in one of them, though they have dependency, shouldn't fail the other component inside this architecture. And another thing which is really important for us is that this data platform should be able to satisfy all data-centric application. It doesn't matter if it is like operational, if it is reporting, if it is analytics, or it is like AI or ML use cases. For example, all the trainings of the ML use like models, they should happen on the data that we have already stored in the data lake. We shouldn't bring like a data somewhere else, like separated from the data platform, and use that data for ML use cases and then have another data for analytics. And another like advantages of having this architecture is that we can have domain ownership. What do I mean by this is that, like, as we can see in this structure, whatever we do on the data till the staging here, it's not dependent on the actual use case of the data that we have. When we are bringing in the raw data into the data platform and we want to put that inside the data lake, we are not caring how exactly we want to put that data inside the table, or like what are the machine learning models that we want to train. The only thing that we care about is to bring the raw data in, have a complete data, have the metadata and everything there. So whatever happens after that is kind of based on the business logic, and it can be owned by different domains like around the organization. For example, when we are like bringing in the source of truth in the staging layer, and if like, for example, the finance department wants to create a data model on top of that, then they have the data, they have everything there, and they can take responsibility to do that themselves. So by having this, we are like kind of making the core data team smaller, and we are putting the business knowledge inside different teams. Like before having this kind of a structure, data engineers, they needed to understand lots of business logics, lots of having so many like business knowledge and spending so many time on that. But now the business knowledge is already existing in other teams, and we are providing other teams with some uh, tools so they can make models themselves. So to go and talk about like event-driven architecture, I will saw like what exactly event-driven architecture is. Imagine like we have several components inside like the platform that we want to build, and these components, they are not aware of the identity of the other components, and the only thing that they care about is the status change in the other components, and also just the statuses that they have already shown interest in. So, and they are like communicating with each other throughout messages or events, and they are not aware of like what exactly is happening to the other components because they are not waiting for them, for example, to become complete. This is what exactly means by asynchronous communication. So what exactly is happening here is that some components, they are not aware of each other. They are communicating asynchronously throughout events. And in this architecture, we have four main elements, as we have like events as the message that we are passing there. We have producers who are like responsible to do a task and send an event or just send an event. And like we have consumers who have already shown interest or they have subscribed to some a special type of events. And then we have event broker or like the event bus, which is responsible to control the flow of events throughout this system. So whenever we are talking about event-driven architecture and data, the first thing that comes to mind is real-time data processing. Like one of the reasons that I was like inspired to have this talk was the conversation that I had with like data people a lot before, that I was like asking them, is your like platform event-driven or event-driven? And they were answering either yes, we are having like real-time data processing, or no, we are having batch processing of data. Then I was telling them that no, I don't mean how you are processing the data. I mean how different components inside your platform, they are communicating with each other. I mean like what exactly will happen when one component is like succeeded and it wants the like downstream components to be executed. And again, like they were answering that, okay, you mean orchestration, right? Because we are using orchestration for years, and like orchestration is amazing. Like we have been using step functions, Airflow for orchestration for a long time. But what I mean here is not event streaming that like contains data streaming under it. Data streaming means we are passing data in real time, we are processing the data, and like though in the background it has event-driven architecture, but it's not what exactly what we mean by components communicating with each other about their states. So what I'm going to talk about a lot today is choreography. Choreography means we have some components that they are completely independent from each other, and they are directly communicating with each other throughout events without any like centralized authority existing there to tell like different components when exactly is their turn to write. So to emphasize more on the difference of like choreography and like data streaming is that when we are doing data streaming, the question that like the consumer is asking from the event is like, what is there? What is the data that I need to consume? But when we are doing choreography, the question that like components like consumer is asking is like, what exactly happened there? In choreography, the consumer only cares about the status change or like the change of a state that it has already shown interest in. So to discuss more about like the architecture of the choreography, like each of these pentagons, they are like one component. And as you can see in this picture, they are directly communicating with each other. If they are passing a message, they are just sending the message to the consumer that has already shown or like shown interest or have subscribed to that. And here we are using like some event broker, like event bridge to control the flow of events. So to talk about the advantages of this architecture, I can start with the fact that components change and scale independently. So if we want to change like one component in this architecture, we are not affecting the rest of the components. And if we want to scale one component, again, we are not affecting the whole picture of the architecture because one component is standing alone for itself and is kind of independent from the rest of the architecture. And one great thing here is that we have no single point of failure. What it means is that if one of the components fails, though there may be some dependencies on the message that this component is sending, but it's not going to make the other components inside this architecture to fail. Another really good stuff here is having adaptability in choreography. What I mean by adaptability is that, like, imagine if today we want to we want to integrate 3 more application and like make them to communicate with the architecture that we already have. We can just add those components and like make them to talk with the other components throughout the message that they already exist, or like with the new message that we are defining them to send. So we are not kind of reconfiguring the architecture that we already had there. So it is really good, like for the example that we were talking about in data platform, that like every day we may have new use case, new application, and we want to integrate with the platform that we already have without modifying the whole architecture that we were using before. To talk about the downsides of this architecture, I can start with lack of visibility. So one problem here is that we are not seeing what exactly is happening, where exactly we are in this flow. Unless, like, if we want to know what exactly is happening, we need to go like query the logs that each of these components are creating. So it's not like the best way to kind of monitor the flow. It is making the monitoring more complex for us. We're not like kind of easily informed where exactly like the flow has failed, or like where exactly we are in the flow. And also, it is a bit difficult to implement error handling, exceptions, and like timeouts on a specific component. Because, for example, when something is happening and it is going inside the retries, it is sending a new event, and like we are not aware of the retry that it has happened there. So it's a bit difficult to configure the timeouts and error handling inside one specific component. So now let's go back to the thing that we love a lot here, like orchestration. It is amazing, and it is making it possible for us to do magic when we are talking about data. And the difference of orchestration and like choreography is that in orchestration, we are having one center of authority, which is controlling the whole flow and which is like sending orders to different states that it is your turn to run now. So as you can see in this picture, components in orchestration, though, like for example, if you imagine a step function, they are passing some events of data between each other, between different states. But still, this event is passed throughout like the authority, which is like the step function or orchestration. They are not directly talking to each other. So in this like session, I'm going to talk about 2 main architecture that we can compare and like decide eventually which one fits our like data platform the best. I'm not going to talk about solely having choreography, like having all like the services inside and like data platform directly like communicating with each other in a choreography manner, because it is not common and like people are not using that at all. But still, having end-to-end orchestration is so common. People are using like end-to-end orchestration by like building a data platform where the first step inside the orchestration is extracting the data from the sources, and like the last step is the consumption. The architecture looks something like this. Like again, like these are different steps that we have inside the data platform, like having the data sources, then doing ingestion, storage, cataloging, like processing and transformation, and eventually like the consumption layer. And in the first architecture, as I told you, I'm going to implement an end-to-end orchestration, which means all these components, all these services, they are going to be a part of one single AWS like a step function. So here I have provided one example. As you can see in this picture, like we have a first step as the ingestion. We take the data from the source, like using the AWS batch job. Then we put inside S3. We run a crawler to create like the data catalog to do the metadata management. And then we do like some transformation, like as I showed you in the like first slide of the structure. We do transformation like for bronze layer, then silver layer, and eventually like the gold layer. So let's talk about the advantages that we have here. First of all, when we are using a step function and when we are just using orchestration, we are having all the logic in one place. Like if I have made this and like tomorrow I give this to my colleague will understand what exactly is happening there by just having one look at the orchestration pipeline. And also, a step function is providing so many like interesting like states, such as like parallel execution, like mapping, fan out, and like different states as pass or like failure, which make it really easy for us to implement different logics. And also here we have visualization. Whenever we execute an orchestration pipeline, we can completely see what exactly is happening there, in which state we are, and what has happened there, which states they have been successful, which states have failed, and like what exactly is going there. So it is also really good for end-to-end monitoring when we have all the steps inside one step function, because we have everything from the ingestion to the last step here, and whenever the pipeline fails, the only thing that we need to do is to just open the step function and see what exactly has happened there. Another great thing is that in a step functions we can have error handlings, retries, and timeouts. Retries, like we can define a retry, like an amount of retries. For example, we can say if this lambda failed here, retry like running that for 3 times, 5 times, or whatever we want. By error handling, it means like, for example, especially like when we have a parallel execution here, for example, this lambda is catching the error. So if when we are running this, if the lambda for silver 1 model fails, it's not going to fail the whole parallel or like the whole step function. And also we can implement timeouts, so we can define like if this function took like so many time to run, just cancel it, like abort the execution. Another great thing is the callback patterns. So many of the services that we are using, doesn't matter if it is inside AWS or we are using like third-party services, they are asynchronous, which means that we are not aware of what exactly is happening when we are executing another service or another job. So in some of the services here, we can define like to make them synchronous. Like for example, in the AWS batch, we can by just like checking the box that it says like wait for the job to be over, or by like defining that to be like synchronous inside like the cloud formation template of that, we can make the step function to wait for that job to be over. But in some other job, we can use like the task token. We can like whenever we execute, for example, a third-party application, we can send the task token to an event bridge, and then event bridge will wait to receive another like message that this third-party application has been done. Now go on, carry on the rest of the flow in the orchestration pipeline. Now let's talk about the downsides of this. Here, like the difference of this orchestration pipeline here from the previous slide is that I have tried to add like 2 more applications here. Here we have like a Lambda that is doing like decision making on the go. Like for example, imagine if the data that we are passing here is the reviews from from social media, and like we want to see if some reviews they have like negative sentiments. We want to do a sentiment analysis here, and then we want to send a message to the customer support team to go check what exactly has happened to that client who has written that bad review there. So when we want to integrate this, the problem that we have with the orchestration pipeline is that like the workflow is so rigid. If we want to integrate a new application, we need to reconfigure the whole step function. Like I needed to change this like crawler and like all the pollings that it has in order to add these like 2 lambda function here as well. So another like problem is that when we are creating so like complex application, imagine like we have 10 applications here inside this parallel. So if one of them runs faster than the others, it should wait for the others to be done so it can go to the next step. So if we put everything inside one step function, like one orchestrator pipeline, we are reducing like efficiency, because we are adding so many dependencies, even though these 2 jobs, they are not dependent on each other at all based on the logic that they have. But because we have added dependency here, we are like reducing the efficiency. Another problem is that by having orchestrated pipelines for the whole flow, we cannot divide the task, we cannot delegate the task to different team members or like different domains around the organization. Because eventually one person should come here and like put all of them together. It's not possible to tell like another team or another member to take ownership of their own application that they are building there. There should be one person who owns the orchestration, and that one person if he or she is not taking the ownership of everything, at least should attend like so many meetings, talk to them on how to like build like this orchestration pipeline and how to integrate everything together. So again, like this is one extra cost, especially like it's not that much like extra cost when we are, I mean, like it's nothing when we are doing batch processing of the data, like the data is not passing in real time. But when we are passing data in real time, imagine we are like executing each of these states millions of times in a day. Then it becomes an extra cost, and it depends on the use case that how we care about this. And like till like 3 months ago, another downside of that was to recover from failure. For example, till 3 months ago, if it has failed here in like the bronze layer transformation, we needed to rerun the whole step function, and like we had already done some jobs here, so it wasn't like the best way. But now, like since November 2023, AWS has introduced the redrive in orchestration pipeline. So if it fails here, we can just tell the step function to start from the failure state. So now let's discuss what we can have with choreography in combination with orchestration. So this is the structure that we had for our data platform. And like previously, we had all these inside one step function, one orchestrator pipeline. But now let's put each of these based on context inside one step function. For example, the ingestion and storage part goes inside one step function. The cataloging or like metadata management goes inside another one. And then like processing and transformation goes inside another step function, and eventually we can have one orchestrator pipeline for each of the applications. And how exactly all of these are going to communicate together using Amazon Event Bridge, which has like an event bus that is kind of waiting to receive like events from different like services around like AWS or like third-party services, and then each of these step functions are like sending an event to the event bus, and then event bus is taking care of the events based on the rules that are assigned there. I will like talk about this in more detail later. So let's go back to the architecture that we had inside one step function. Like this is the step function that we had in the previous example of the first architecture. And now we have been like breaking up each part of this orchestrator pipeline based on the context. For example, like the ingestion one has become its own orchestration pipeline, and it's by the end of it, it is sending an event to event bridge. Then like the Lambda function that was doing the real-time decision making for us, it's becoming its own orchestrator pipeline. And for example, like the glue crawler that was taking care of the metadata is its own orchestrator pipeline. By doing this, for example, whenever we want to run like the crawler, we can have like modularity here. For example, like we have some jobs, especially from the data source to the staging layer, where what we were doing was not dependent on the data. We were doing the same thing on all the data. Then by doing this, we can have modularity. For example, if we replace these like starting crawlers with some lambdas, then we can have just one orchestrator pipeline with a crawler, and we can just pass the name of the crawler that we want to run. So we don't need to put one crawler like everywhere inside the orchestrator pipeline or everywhere inside different pipelines. We can have just one crawler for the whole like metadata management that we are doing, and every time that we want to send an event to run a crawler, we can send the name of the crawler that we want as well. So we are going to have lower amount of code, and we can have like modularity here. So this is a better like kind of picture of the architecture that we're talking about. So we have now one step function for data ingestion. We have one step function for data cataloging, one for transformation, one for staging, and one for each of the applications that we are building on top of the platform. And we can also integrate this like with like third-party application. Like for example, we're using like DBT for transformation, and we have some DBT orchestration somewhere else out of the AWS service. But still, we can communicate to that orchestration pipeline, and we can receive messages when they are done. And also, as I said, like maybe the extra cost is like considerable for someone and they don't want to put everything inside a step function. For example, if we are using Amazon Kinesis, and like this is one job of Amazon Kinesis and it has its own context, maybe it's not necessary for us to put that like Kinesis job inside a step function. We can have services like standing alone for themselves as well. So what exactly is happening here is that each of these step functions or services, they are sending an event based on their state to Amazon Event Bridge. And in Amazon Event Bridge, we have some event rules that these event rules, they have a pattern for attached to them. And each of these event rules, they have a target. For example, imagine when the ingestion is done, it will send an event to Amazon Event Bridge with the source as ingestion pipeline. Then in Event Bridge, we have a rule that in that rule, we have a pattern that this pattern contains the source as ingestion job. Then we may have like the data catalog, a step function as a target of that rule. So whenever a message comes with that pattern, having that rule, the next step function will run. By doing this, we are creating the flow, but we are like making different part of this architecture communicate throughout events with each other. So here I have randomly like throw some applications of data on here to see what exactly is happening based on what we talked about. So each of these each of these components here, they can be a step function for them or they can be a service for them. But what is important here is that each of these, they have their own bounded context. So whatever happening in ingestion is just about ingesting data. Whatever happening in silver is just about the transformation that contains like the silver layer. And by this way, if I like throw 5 more applications here, I can just make them communicate with the previous setup by passing more events and like or subscribing to the events that we previously had. So let's talk about the events that we are using here. You remember in the slide that I was talking about breaking down the big step function into a smaller step function, we were having put event by the end of the orchestrator pipeline for different contexts. So we can define some like custom events ourselves, or a step function, they have a really good thing, which is like events that they are showing the status changes inside the step function. For example, here, this event contains like the status as failed. So whenever this step function fails, it will by default automatically, without us telling the step function to do that, it will send an event to event bridge that this execution with this execution on, and for this state machine has failed here. So we can, instead of like defining custom events ourselves, use, for example, for a step function, use the status changes event that these step function, they are like sending by default. But like here, for example, in this example, we have one rule here that this rule has like this, the pattern that this pattern has all the step functions that they have like in their ARN, they have this as their prefix, as their prefix, and like they have this as their execution ARN. And we are just telling this event rule that only responds to events that they are having the status as failed, timed out, or aborted. And we are using this rule for monitoring. So we have put it there, and like we have connected, we have attached a lambda function as a target to this rule. So whenever any step function in our system fails, it will send a message like this to our Slack, and like we have implemented a link here, like we are recreating the link to that execution. So just by clicking on the link, we can see what exactly has happened inside that failed step function. So by just having one rule and like making one rule to respond to all the step function that they have like this prefix in our system, we are doing monitoring on the whole system. So eventually, like what I want, like my message here is that, first of all, the characteristics of the data platform. We want the data platform to be adaptable to new applications, so we can integrate everything with the lowest amount of effort. And the message here is to, whenever we have Like a bounded context, it's better to put the logic of that bounded context inside one microservice as an orchestration pipeline, and we can have this bounded context to communicate with each other throughout choreography by passing messages directly to each other. Thank you for listening.